All right, let's go ahead and get started. Today we're going to be doing lecture number 30, SOL Review Part 5. And today I wanted to look at the Spring 2015 SOL. Okay, let's get started. So number 1 says, which expression is equivalent to the square root of 20 x to the 16th power, y to the 25th power? So under the square root, I'm going to put a 20, an x to the 16th power, and a y to the 25th power. So if I want to simplify something like this, I'm always going to start with the number first. This 20. Is there any way that we can break this down into perfect squares? What's the biggest perfect square that'll divide into 20? Was anybody able to get that? Okay, let's use a 5 and something else. So what's 20 divided by 5? 4. Good. So I'm going to put a 4 right here. And I'm going to circle it because that's going to be my perfect square. Okay, so now what I want to do is I want to rewrite this. I'm going to use 5 times 4. So just breaking up the 20 into 5 times 4. That's all I'm doing right now. And I'm going to underline the 4 because I'm going to take that out. And then I'm still going to have the x to the 16th power and the y to the 25th power. Those stay the same for now. So now I can take the 4 out, but it's still under the radical, the square root symbol. So what's the square root of 4? Was anybody able to get that? Square root of 4 is going to be 2. Good. So I can take out the 4 as a 2. But the 5 is not a perfect square though, right? So I've got to leave the 5 under the radical. So when I draw my square root, I'm going to leave the 5 in, as well as the x to the 16th power and the y to the 25th power. Okay, so now let's do the variables. Whenever you're taking out exponents, you're taking the square root of these exponents. That means that you can divide them by 2. So we're going to take out the x's and the y's in groups of 2. So for the first one, I have x to the 16th power. What's 16 divided by 2? Good, 8. So I can take out x to the 8th power. And since that evenly divides by 2, I don't have any x's left inside the radical. So now let's do the y's. How many groups of y's can I take out? What's 25 divided by 2? What would that be? 25 divided by 2. How many 2's can I take out without going over? So what are we thinking? 12, right? I'm going to take out 12 y's. And I know that's going to be correct because what's 25 divided by 2? 12 remainder 1. So what that means is I'm still going to have a remainder left inside the radical. So when I draw my square root symbol, I'm going to go ahead and put the y under there with the 5. And Connor, can you sit in front of Denasia today? Yeah, right there. Awesome. And there we go. The only thing that should be left under the radical is a 5y. So what is this going to be? A, B, C, or D? Looks like it's going to be C. Now, when you get done with this, you want to make sure that there are no more perfect squares left under the square root symbol. As long as all the perfect squares are outside of the radical, you're done. Now, we know that 5 is not a perfect square, y is not a perfect square, so those are going to be left inside the radical. Let's look at number 2. All right, so number 2 says we got the cube root of 6w to the 7th. Cube root 6w to the 7th power. And we're multiplying it by another cube root. Four w to the 5th. Okay, so for this one, they're both cube roots, which means we can combine the radicals. So what I'm going to do is I'm going to write this as only one cube root. And there's going to be a lot under the cube root because I've got 6 times 4. 6 times 4 is going to give me 24. So I can put a 24 under the radical. I've also got w to the 7th times w to the 5th. And if you add 7 and 5, you're going to get 12 w's. So I'm going to put w to the 12th power under the cube root. So all I'm doing so far is I'm multiplying together what's under the cube roots. All right. Now for the 24, I want to find the biggest perfect cubes that I can take out of 24. What's the largest perfect cube that I can take out? What'll divide into 24? Now I can't use 4 times 6, right? Because those are only perfect squares. I need a perfect cube. Let's use 8 and 3. 8 times 3, that's 24, right? And what I'm going to do is I'm going to circle the 8 because 8 is a perfect cube. So what I do is I can break up the radical. So go ahead and rewrite. Make sure you put a 3 as the index for the cube root. And I'm going to write this 8 times 3. Eight times 3. And I'm still going to have w to the 12th power under there. That hasn't changed. Okay, so I'm going to underline the 8 because I know that 8 is a perfect cube. What is the cube root of 8? Was anybody able to figure that out? Cube root of 8 is 2, right? And this is because 2 times 2 times 2 is equal to 8. So I can take out the 8 as a 2. But this 3 right here has to stay under the radical. So when I do a cube root, I have to keep that 3 under there, along with the w to the 12th. So now the number is done. Let's work on the variables now. Now for a cube root, you're going to take that exponent, that 12, and you're going to divide it by 3. So what's 12 divided by 3? 12 divided by 3? 4. So I can take out 4 of the w's. Since that divides evenly, there's not going to be any w's left under the radical, right? The only thing that should be left under the radical this time is this whole number 3 here. So I'm going to put that under the radical, and I'm done. So once you get done with this, there should be no more cubes left under the cube root because you should have taken them all out by now. So let's go ahead and take a look at our answer choices. So the answer is going to be A. Two w to the 4th power times the cube root of 3. All right, let's look at number 3. Okay, so this one gives you a bunch of steps. I'm only going to write down 2 of them. Step 4 and step 5, because this is really what the question is asking. So this one says the steps used to solve an equation are shown. What this is trying to do is it's trying to solve for r. So I'm trying to get r by itself. Step 4 says 1 times r. 1 times r is equal to 21i. And then step 5 says r equals 21i. 21i. And then it asks which property is going to take us from step 4 to step 5. So for this, the only difference between step 4 and step 5 is we're multiplying by 1. And if we multiply something by 1, that doesn't change anything about it, right? So we're just multiplying by 1. That's what I'll say. So which answer choice best matches up with that? The identity property of multiplication, the inverse property of multiplication, the commutative property, or the associative property. So commutative means it doesn't matter which way you multiply things. You're still going to get the same answer in the end. And the associative property involves grouping, and we know that that's not happening. The inverse property is when we multiply by a reciprocal, and the identity property is when we multiply by 1. So the answer is going to be the identity property, A. So that's called the identity property of multiplication. Okay, I'll leave that up there. And then we'll try number 4 in just a minute. Okay, let's try number 4. Okay, so this one is a complex fraction. And you can tell because you've got a fraction on top of a fraction. So let's go ahead and write this out first. We got 11 minus w. And on the bottom, we have 30w squared. And then we're going to have an even bigger fraction bar because we're going to have a fraction in the denominator as well. W minus 11 over 5w to the 6th power. So we have a fraction on top and a fraction on the bottom. Whenever we do complex fractions, I always want to keep the first fraction the same. So we're going to keep this fraction the same. The fraction on top is always going to stay the same. The fraction on the bottom is going to be flipped. So we're going to flip the bottom fraction. So the first fraction on top says 11 minus w over 30w squared. I'll put my multiplication dot in the middle. And what we're going to do is we're going to flip the fraction on the bottom so that it's 5w to the 6th power on top and w minus 11 on the bottom. Okay, so now let's see if we can simplify this a little bit. We can cross cancel and see what we can cancel out. Now, the first thing that I can do is I can take a -1 out of the top. See how this is 11 minus w and this is w minus 11 at the bottom? Well, what we can do is we can take a -1 out. And then on the inside, we can flip the order. So it won't be 11 minus w, it'll be w minus 11. So now we've taken the -1 out. What we can do after that is we can cancel out the w minus 11 on the top and the bottom. So now that those are gone, the only thing that should be left on the top of the first fraction should be this -1 right here. Now what about these two right here? I have a 5 on top and a 30 on the bottom. That means I can divide both sides by 5. So if I divide this by 5, I'm going to be left with a 1. And if I divide 30 by 5, what do I get? 6. So now the numbers are gone. They're replaced with 1 and a 6. Now I have 2 w's on the bottom, 6 w's on the top. If I get rid of 2 of the w's at the bottom, I can cancel out the w squared. I have to get rid of 2 of them at the top as well. So this 6 is going to change into a 4 since I just got rid of 2 of the w's. So now what's left on top? I've got a -1 times a +1. That's going to be a -1. So I'll just put the negative sign right there. And I'm going to have w to the 4th power on top. And then what's the only thing that's going to be left in the denominator? The 6. And now that there's nothing left to cancel, we're done. So which answer choice best matches that? It's going to be A. So that's number 4. All right, let's look at 5. Five says, what is the complete factorization of this polynomial? Let's write it out. I'm going to have 18x to the 4th power plus 12x cubed minus 6x. Now for this one, it kind of looks complicated, but what you need to keep in mind is you can always take out what they all have in common. So what do all 3 of these terms have in common? They all have an x, so I can take an x out. What else do they all have in common? As far as numbers go, they all can be divided by 6. So they all contain a factor of 6. So I can put a 6 in front of the x. Now I just need to see what I'm left with. We're going to divide everything by 6x because that's the GCF that we just took out. So I'm dividing it by 6x. Okay, so I'm dividing everything by 6x. 18 divided by 6, that's going to give me a 3. X to the 4th power divided by x, that's going to give me the 3rd power. We're just subtracting the exponents. Over here on the second term, we have 12 divided by 6. That's going to give me a 2. X cubed divided by x is going to give me x squared. Because I have 3 x's, take away 1. And then over here, everything is going to cancel out. So I'm just going to have a -1. And I'm done. There's no way I can factor what's on the inside. Now, whatever we take out from everything, I'm going to underline in red. So this right here, this 6x is called the greatest common factor, the GCF. That's what all 3 of these terms have in common. So which answer is best for this one? Yep, D. Okay, let's try number 6. So for this one, we have I to the 75th power. I to the 75th power. So let me refresh you on the powers of I real quick. And there are really 5 of them that I want to look at right now. Okay, so as you probably remember, I is the imaginary unit. Which means it's an imaginary number, not a real number. I is going to be equal to the square root of -1. It allows you to take the square roots of negative numbers. And what we're going to do is we're going to take the exponents of I, the powers of I. So anything to the 0 power is going to be 1. So the first one is going to be 1. And then if you take anything to the 1st power, well, nothing changes when you take something to the 1st power, right? So I'm going to be left with I. And then we can start taking even higher powers of I. So what's I squared going to be? I squared is going to be square root of -1 times square root of -1. That's going to give me -1. But then if multiplied by I again, we're going to get -1 times I. And that's going to give me -I. And then the last thing that I'm going to do is I'm going to multiply by I one more time. So I'm going to take this -I right here, bring it down, and then multiply it by I one more time. I get -I squared. We know that I is -1. So -1 is going to be a +1. So I to the 4th power is going to be 1. What this tells me is I need to divide the exponent by 4. So we're going to take this exponent and we're going to divide by 4. So the reason why we're dividing by 4 is because the exponents repeat themselves. Well, the answers are going to repeat themselves every 4 times. So see how this 1 is repeated down here? So the answers are going to repeat themselves every 4 times. So we're going to take this 75 and we're going to divide it by 4. Okay, so what's 75 divided by 4? I know that 4 can go into 7 once. 1 times 4 is 4. And when we subtract 7 and 4, we get 3. And then I bring down the 5. So how many times does 4 go into 35? Only 8 times without going over. Because 8 times 4 is going to give me 32. And when I subtract, what's my remainder going to be? My remainder is going to be 3. So I'm going to write R3 at the top. Now, it's this remainder that's going to help us. So I'm going to put a box around it. So what's I to the 3rd power? I to the 3rd power is going to give me -I. Yep, that's my answer. So we take this remainder, we make it the new exponent down here, and we get -I. So that's going to be B, -I. Okay, let's try 7. We've got x squared plus bx minus 60. And we want to figure out what b has to be to make this factorable. So whenever we factor, what we're trying to do is we're trying to multiply to the last number. I'll put a box around it, -60. And we're trying to add up to the middle number. So I'll put A above that. So what two numbers can multiply to negative 60? We can use 20 and 3. We can use 6 and 10. We can use 15 and 4. And there are some other ones too, like 1 and 60. So we're trying to find pairs of numbers that multiply to 60. But of course, it's going to be a negative 60. That means that one of these is going to get the negative. So now, what are our choices for adding? We have 61, 23, negative 7, negative 16. So let's write those down. We've got 61, 23, negative 7, and negative 16. So which one of these can we add up to? Well, we can't add up to 61. That's for sure. That's because both of these have to be positive, but one of these is going to be negative, either the 60 or the 1. So there's no way we can add up to 61. How about 23? We can't add up to 23 either, right? Because one of these has to be negative right here, the 20 or the 3. And if the 3 is negative, we're only going to be able to add up to 17, so that's no good. Can we add up to a negative 7? Maybe we could, so I'll put a question mark beside that. And negative 16, is there any way we can add up to that? Only if both the 10 and the 6 are negative, but only one of these can be negative. And if we put it on the 6 or the 10, there's no way we can add up to negative 16. So I'm going to cross through that. So the only one that seems right is going to be the negative 7. Now, how can we add up to a negative 7? Let me erase this B right here. And I'll put a negative 7 right there. So how can we multiply to negative 60, but still add up to a negative 7? 12 times 5. 12 times 5. If we put the negative on the 12, then what's negative 12 plus 5 going to give us? Negative 7. So these are the only two numbers that'll work. Which means that this middle number has to be negative 7. And that's going to be C. So we're always multiplying to the last number, negative 60. But we're always adding up to negative 7, the middle number. Okay, let's look at 8. So 8 gives us a fraction times a fraction. We got 25 minus 4x squared. We're going to be able to factor that eventually. And in the denominator, we have 6x squared plus 9x minus 15. And we're going to multiply that by this fraction right here. 6x squared minus 2x minus 4. And in the denominator, I have 2x squared minus x minus 10. Okay, so let's factor everything that we can. Now at the top, I have a 25 and a 4. I can break those down as squares. The square root of 25 is 5. And the square root of 4 is going to be 2. And I'll put an x beside that. I'm going to have 5 minus 2x, 5 plus 2x. So that's how I would factor the top. Now in the denominator, what can I take out of everything? The 6, the 9, the negative 15, they can all be divided by 3. And when I take out that 3, I'm going to be left with 2x squared plus 3x minus 5. Over here on this side, I can take out a 2 from the top. When I do that, I'm left with 3x squared minus x minus 2. And then the denominator, I still have that 2x squared minus x minus 10. I can't take anything out from that. Okay, so now let's factor what we have left. So the top is going to remain the same. I've still got 5 minus 2x times 5 plus 2x. In the denominator, I still have a 3. And then I want to see if I can factor this. So to multiply to 2x squared, I'm going to need a 2x and an x. If I'm trying to multiply to 5, I'm going to need a 5 and a 1. I'll put the 5 right here and the 1 right here. And then I have to see which one's going to be the negative. Well, I'm adding up to a positive 3 right here. Which one gets the negative? It's going to have to be the 1. So that way, when you fill back, you'll get 5x minus 2x, and that's going to give you the 3x. Over here for the second fraction, I'm still going to have that 2 on the outside. And let's see if we can factor this thing right here. To multiply to 3x squared, I'm going to need a 3x and x. And then to multiply to negative 2, I'm going to need kind of 2 and 1. I'll put 2 right here and 1 right here. So that way, when I multiply, I'm not going to get 6x. I'll just get 3x and 2x. Where does the negative go? It's going to go on the 1. So that way, I have a plus in front of here. So the reason why I did that is because when I FOIL, I'm going to get 3x times negative 1. That'll give me a negative 3x. And then if I add 2x, I'll get a negative 1x right here. Okay, let's factor the denominator. I'm going to need 2x and x. How do I multiply to negative 10? Let's use 5 and 2. I'm going to put the 2 right here and the 5 right here. Which one is going to get the negative? It's going to have to be the 5. The 2 is going to be positive. So now, what can we cancel out on both sides? The first thing that I see is I have a 5 plus 2x right here. That's the same thing as 2x plus 5 down here, so I can cancel those. So those are gone. What else can I cancel out? I see that I have an x minus 1 down here, right? X minus 1 up here. Now I've also got a 5 minus 2x right here. That's almost the same thing as this 2x minus 5. If I can take a negative 1 out, they'll match up. So now I can cancel the 5 minus 2x with the 2x minus 5. And now there's nothing left to cancel out. I'm done. So now let's multiply these together. I'm going to have negative 1 times 2. That's going to give me a negative 2. And I have 3x plus 2 on top. What do I have in the denominator? I've got a 3. That's over here. And an x plus 2. And I basically got that from right here. So this is going to be my answer. So does this help with anything? It's going to be C. All right, let's try number 9. So 9 is going to give me 2 fractions. I've got 12 over x plus 1. And I've got 1 over x minus 4. So if I want to add 2 fractions, I need to find the lowest common denominator. The first thing that I notice is this one is missing the x minus 4. So when I rewrite this, I'm going to keep the same. I'm still going to have 12 on top and an x plus 1 on the bottom. But I'm going to multiply the top and the bottom by x minus 4. Over here for this fraction, I'm going to keep everything the same for now. I've got that 1 on top and an x minus 4 on the bottom. But I notice that this one is missing the x plus 1. So I'm going to multiply the top by x plus 1 and the bottom by x plus 1. So now I have a common denominator. The bottoms of the fractions are now the same. So now I'm going to write everything as one fraction. with an x plus 1 and an x minus 4 on the bottom. So on the top, I have 12 times x minus 4. 12 times x minus 4. But over here on this fraction, I have 1 times x plus 1. So now I can simplify the tops a little bit. What I'm going to have to do is the distributive property. I need to multiply everything in here by 12 and everything in here by 1. So let's do that. So if I multiply the x times 12, I'm going to get 12x. 12x. If I multiply the 12 by the negative 4, I'm going to get negative 48. Over here, if I multiply everything by 1, nothing changes. I'm still going to have x plus 1. And the denominator is plus 1 x minus 4. So now I've done the distributive property, and the only thing that's left to do is to combine like terms. So when we combine like terms, notice that this 12 has an x beside it, and this 1x also has an x beside it. So we can put these two terms together. 12x plus 1x 13x, right? And now we put the numbers together. Negative 48 plus 1. What would that be? Negative 47, right? So I get 13x minus 47 on top. What's in the denominator? X plus 1, x minus 4. We just combine like terms. There's nothing left to factor. Notice the top doesn't have anything in common, so we can't factor that. We're done. 13x minus 47. So that's going to be A. Okay, let's do the last one we're going to do today, number 10. So 10 gives us a square root. And it asks us to simplify. So inside the square root, I'm going to have 36x to the 9th power. And then I also have y to the 25th power. So what I can do is I can start off by taking square roots. The first thing that I notice is 36 is a perfect square. What's the square root of 36? That's going to be 6. So I can take the 36 out as a 6. But I'm still left with some variables on the inside. I've still got x to the 9th, y to the 25th. But we're going to take the variables out as pairs, which means we're going to divide the exponents by 2. So what's 9 divided by 2? we can take out 4, right? But there's going to be 1 left over. And I keep that remainder under the radical. So I can take out 4 pairs, but I'm still left with 1 remainder. We keep that 1 under the radical. Now let's move on to the y's. How many y's can I take out? So we have 25 on the inside, 25 divided by 2. Yeah, 12. So we can take out 12. But we're going to be left with a remainder of 1. So one of the y's has to stay under the radical. And we're done. There's no more perfect squares that we can take out from the square root. All the remainders have to be left under the square root symbol. So this is going to be which answer choice best matches up. That's going to have to be B. Now B, it actually writes it a little bit differently. It actually kind of writes it like this: x to the 9/2 power and y to the 25/2 power. Yeah. So these two answers are actually the same thing. It's just that they're written a little bit differently.